Hello there. I haven't posted a video in a while. It's probably been my longest stint without posting a video. I've been waiting a really long time for something to come in the mail, and I'm pretty sure the person who was sending it to me basically just forgot about me multiple times. Anyway, so somebody sent me this. A nice gentleman who bought some stuff for me. He was getting into the Amiga, and he had this mouse and it didn't work. And it's a Manhattan mouse, and it works with Amiga and Atari with this switch. I tried to look this mouse up on the internet, and it seemed like it was something that was made. Ooh, look at that. That needs to be addressed, most likely. See that? He said he tested continuity on it, and it didn't work. It goes one way and not the other. I forget if it was the horizontal or the vertical that's not working, but hey, it's the only content I have for now, and there is more content coming eventually. So stay tuned, and please don't unsubscribe. My Raspberry Pi videos were incredibly popular compared to my normal videos, not compared to the successful YouTube channels. But anyway, so this, we're going to test it out and then try to figure out what's wrong with it. It's a ball mouse. Yeah, okay. Let's plug it in and see what it does. So we have Amiga test kit up here, and yes, indeed, it only goes up and down and not side to side. Let's see. Oh, I don't have a keyboard hooked up. He said, I think he said that the buttons worked. So anyway, let's I guess we'll verify that the horizontal does have continuity. I mean, I don't want to distrust the guy or anything, but always what you do when you repair something is you verify the symptoms and you test everything, even if the person before you has not. By the way, the gentleman who sent me this, his name is Sean Pratt, and he wanted me to plug his things, so check the description. Yeah, he said maybe you can give me a small plug in your video. Underground Studio. I do guitar, pedal board, and have a band trying to get the channel going. So Underground Studio, and he never sent it to me. I guess I'll ask for it so I can put it in the description. So anyway, Sean at Underground Studio. And you know, I'm grateful to him in the fact that he went to my store and he bought a couple of items because he got a hold of an Amiga, and you know, obviously when you get them, they rarely ever have everything you need. They either are missing a mouse or they're missing a way to hook it up to your television or monitor, and that's the point of my eBay store. Or they're missing a way for you to load discs in them. It doesn't have any discs, or the drive doesn't work, or something like that, or the discs don't work. So that's the reason why I sell three things on my eBay store. I sell the HDMI and VGA adapters, so you can plug your Amiga into a modern TV or monitor. I sell Gotex that are already modded up, so you can actually use a thumb drive to load your discs on it. And I sell mice kits. At least I'm trying to. The parts availability has been difficult, but I'm making headway in that regard. So anyway, let's go take this mouse apart and see. A lot easier to get apart than some other mice. Best way to do this is good for cars too, is you just get a push pin, you know, like a sewing pin, and and just use your alligator clips, you know, on your probe. And if you don't have probe leads with an alligator clip attachment that screws on, then you need it. But you could do this, and you can pierce into wires. It's great for automotive work and stuff like that, where you're trying to test stuff, and you want to do what they call back probing. So let me look up real quick. I'll probably throw something up on the screen. There it is. Okay, so pin 2 is the third one over here. And pin 4 nope. Close, but no cigar. You know, it's like there's a resistor inside the cable. Or the cable's bad. That's really close. See now that? Okay. See if we can hold it in there. Down the side or something. Oh. Let's choke up on the bat here a little bit, and the other ones I was able to get it down the... There we go. Look at that. It's all over the place. Huh? I just want to isolate it. It could be here, it could be a little bit further down where I'm wiggling it. Still not the greatest continuity, even at best. Full continuity is 006. So that's really, really rare. Usually when you have a bad cable, it's an open, it's a full open, it's an actual break. This is two wires that are broken, but they're super close together. And I forget what my multimeter specs out at, but my multimeter, when it's doing continuity diode test, it's sending a volt or two through it. And that's enough to jump over that small gap. As I'm wiggling it around, I'm making that gap go further away and closer together. And the spark has to, that 1 volt spark has to go across a longer distance. That's more resistance. So that's basically what's happening. But usually when you have a break, it's enough of a break to not be, I mean, it's really so close that you wouldn't even be able to see it visually if you somehow x-rayed into it or whatever. But anyway, that's what I think's wrong with this mouse. So we're going to get another cable. And let's see what we're going to do here with this connector. Obviously this is meant to be a replaceable part, which is nice. And how does this stress relief thing work? Oh, well, it's pretty basic. But it was out like this. So that might even been the gentleman who I got this mouse from. But yeah, I'll bet that if I replace this cable, and I'm going to have to solder you know, this onto there, which means I'm going to have to pin out the entire cable, which is a pain. So I'm going to take this continuity tester and I'm going to pin out every single one of these by color, and then I'm going to replace the cable, because you're never going to get two cables that have the same color scheme on them. Okay, so I got these real nice cables here that even screw in, and they're actually serial cables, but they work really well for mice. The only problem is got two problems. Minor problem, it's not quite as long. That's how much shorter it is, 4 inches or whatever. That's no big deal. But the other problem, bigger problem, is that the new one is thicker than the old one. So yeah, there's a nice thick piece of insulation on this thing. So that means that when it comes to putting it in here, we're going to have a problem. So, you know, it's just not gonna go in there. Well, maybe if I squeeze it just right, it will. This thing locked in there. Let's see here. Just see if we can squeeze it in there. No. So I'm going to make the executive decision of widening this hole, because this cable is really good stuff. So it looks like this has an ability to do a middle mouse button, but it's not wired for it on the... Looks like you could put a wider connector on here too. Not implemented. Alright, so but first things first, we're going to take these wires and solder them to this and hope there's no problem. I guess I'm going to have to cut them kind of short. It's not like I have a ton of room in here anyway, inside this mouse. If I put too much wire in there, it's going to interfere with the mouse buttons. I'm going to run it in. I don't know what I'm going to do about this post here. I can widen this hole and bring this in. The cable's supposed to come in here and then take a right turn and go around that post for stress relief. But I'm not going to be able to do that because it's too thick. So I'm going to come straight in and then maybe loop around the post. Although, oh yeah, you know what? I might be able to get the wires underneath this. That's probably what, oh, that's perfect anyway, because there's nothing on top of this really that I can see that would hold wires in it, you know? So if you wiggle this enough, I'd almost imagine that other cable just kind of wiggling itself out of there and just being loose in there. That might have been actually what happened. But because the entry point of the cable here doesn't go all the way to the floor, the inside floor of the mouse, but this post does, I should be able to come through and wrap it underneath this thick cable and out. But anyway, so we'll get started with, so how much do I need? Maybe something like this. Something like that. This cable is really nice. It has a shield in it, and then it's got the foil shielding around it, and then it's got, you know, a fabric dielectric running down the center. It's almost like Cat 5e or Cat 6 cable. All right, so the nice part about this cable is I already have the pin out that matches the colors. So, for instance, pin 1 is black, and pin 2 is violet, so this is new, this is old, so all I need to do is hook the gray of the old, cut this off, take the gray from this, put it on the orange of this, and go on down the line. The most efficient way to do this is to strip them all and tin them all. These, by the way, I should put a link to these in the description. These are wonderful. These are the best strippers. People, well, there's other strippers. People swear by certain strippers. Look at that. See that? And how many other strippers can strip more than one wire? I usually do 3, sometimes even 4 at a time. One of the things about soldering wires that are insulated is, I don't know if you've noticed, I'm sure you have if you've done it at all, the insulation heats up and retracts. And so you think, you know, that usually happens. It pretty much always happens, with, especially with thin gauge stuff. And it really just means that you just have to go back over and chop them down. And when you see the insulation receding, go ahead and follow it with your solder. Chase it, because you're going to be cutting the end off. So now what this should do, if you were to test, I'll demonstrate a good way to test this if you were worried about it, is you would run the same test that you did. It's a test also to make sure that our continuity from these solder joints down to this connector are good also. Is white. There it is. So unless there's something else wrong with the mouse besides the cable, because believe me, that cable there was something wrong with it. No full opens as opposed to dead short. No full opens, yet it wasn't working. You know, there was some continuity there. And that'll trip you up. That will trip you up. Okay. All right, moment of truth. Guess what, guys? It didn't fix it. Nope. Just take the bottom cover off here and just spin the wheel manually. Oh yeah, we're good there. The other direction, nothing. So first attempt at repair is a fail. That cable was problematic though. Unless, does the cable have built-in resistance? No, because, I mean, it shouldn't. It was changing its resistance when I was moving it around. Wait a minute. Okay, yeah, this is fully mechanical. This is a fully mechanical part. So when you go side to side, it's rotating this wheel, and it's these two, this LED and this photoresistor. And then the only other thing we need to do is, with very high magnification, is check. These solder joints are pretty good, you know. There's not a issue with lack of solder. And on cursory examination, I don't see any broken joints. And I can always test continuity between the connectors, such as the LED and photoresistor are both in the same line. And there. Good there. And good there. So no broken solder joints there. I tested the switch, but really if it's broken solder joint, I need to test the pin of the switch to wherever it goes for a proper test. Third one here. And two, oh, this one. We're good there. Yeah, so we're good on the switch and we're good on the LED solder joints. It looks like we're good on the connector. Although, let's do 2 and 4 here, since we know that's what we're dealing with, and see. Wait a minute, I'm in 4. Yeah, I'm in 4. And 4 is orange, which is the third one. Okay, so that's good. The solder joint for number 4 is good all the way into the board. And number 2 is brown, which is the 4th from the left, right here. 1, 2, 3, 4. Oh, that's the one that's not being used. So this is it right here. It is the first one over here. Wait, what? Whoa. You got to see this. I think I found the problem. It's kind of something that's deceptively simple. Okay. So that's pin 4. It was actually on pin 2, which is the 4th from the left. So let's count. I got 1. This one's the blank one. This one would be pin 5, but it's not going to. 1, 2, 3, 4. Okay, so we got this one. Okay, follow this one around. Comes around here. Goes around here. It's along the edge of the board, and then how could you miss it? A cursory board examination would have told you. It just, I didn't notice that notch, and when I saw it, I thought it was normal. That was stupid. If I looked on this side, I could tell you could tell it's a crack, that a piece broke off of it. So that would explain it. So we just need a bodge wire. Yeah. So that would be a board inspection fail. I looked at the cable. That's a lesson to be learned. I looked at the cable. You know how it was uninsulated coming out of the mouse, and I sort of let that dictate the direction. Of course, you have to admit it's much more likely to be the cable, but still, due diligence and all that, you know. Like maybe I didn't have to replace the cable, you know. Comment below if you feel I didn't need to replace the cable. It had resistance on it though, and it changed when I wiggled the cable. All right, we're starting Amiga test kit again. We're expecting success this time. Yes, we have. Doesn't work real well on this wood, I think, but I click the button. you know, I think I need to adjust the tension on this. The ball kind of, in my mind, it kind of wiggles around too much. So this device here is spring loaded. It's supposed to be, and it's what keeps tension on the ball in this direction, and that keeps it against the shaft that comes down here and the shaft that goes across here. But this is literally like loose. I'm not sure what's going on there. So I don't think we're quite done with this mouse. Let's see. First thing I'm really gonna do is heat shrink those guys, but let's just check this out real quick. This has absolutely no tension on it. I don't know why that would. So it's supposed to be all the way up. Oh, wait a minute. It wasn't all the way up. And could that be because there are these little holes here in the sides, right here and right here, and there's little thumbs on this white piece of plastic that are supposed to go in there. And oh, okay. Yeah, we have a failure here. That's what the problem right there. It's a crack right there. So, and because that crack is there, the crack, and what's this? Wait a minute. See that shiny stuff? Here, oh, hey, earthquake. See that shiny stuff? That's glue residue. Somebody tried to glue this together because they knew there was something wrong with it. And, yeah. Most people off the street, you know, the layperson, they actually don't know how to glue something like this. I'm not going to say that I'm 100% successful in gluing stuff like this, but I'm, you know, eventually. I mean, sometimes I have to try a couple of different techniques, but I've learned over the years that you really have to clean the area. Let's take a really close look at this thing. It's cracked all the way, and that wheel, tension wheel, isn't going to stay in its place. And somebody knew that already. Somebody already diagnosed this and tried to glue it, and they didn't. And this is super glue. Super glue, always some sort of super glue, CA glue. It leaves that residue on there. Unfortunately, some plastics just are very resistant to super glue. And I'm just going to put this down here and see something here. So the crack, I'm going to lose that spring, aren't I? Did I already lose it? It's right there. Mr. Spring wants to get lost. Okay, so depending on where this is located, I have plenty of room around here. So epoxy, I think, is the way to go. Some epoxy on the outside of this. So we just have to be mindful of the screw going in here. So, you know, that would be the only concern. But yeah. So actually, the other there's two ways you need to prepare or think about prepping a surface before gluing. One of them is sanding or filing, and the other one is using a solvent to clean it. But I think trying to apply glue inside this joint, like the last person did, is probably, I mean, why not learn from their mistake? So I'm going to just take some epoxy and put it here, very thin layer here, and another gob there, just to hold this bad boy in there. I'm a little bit concerned about this top piece where the mouse is the mouse tensioner, the ball tensioner goes. You know, this is the reason why the ball tensioner doesn't stay in place. That is the reason right there. So if I can get a dab of epoxy around there too, that would be great. This goes this way. I seem to have enough room. Doesn't seem to interfere with anything mechanically. So yeah, a little thing of epoxy over there. I'm going to go ahead and go for the file method. It just seems like it would be a good idea to remove the glue that's there because it didn't stick, right? So if I put my epoxy over the glue that somebody else used, that glue is just going to come off, yeah? So what would make this crack and also the board crack? Somebody step on it? Somebody threw it across a room or something? I'm going to apply glue here. And there should be, yeah, there's enough room for me to get around here. So the glue's going to go around like this and follow the crack. And then I'm just going to load it up in this area. And then I'm going to take a string or two and wrap it around here. Have a gob on this corner, I guess. Should just go in there. Yeah. There we go. All right, so let's take a look at our, it's just the slightest bit tacky, so it's all good to go. The reason why this looks all messed up here is because I put a piece of paper here. I yanked it off when it was almost dry. I was trying to push this together, and obviously you don't put your fingers on epoxy. So I just put a piece of paper. That's a pretty good technique. I mean, the paper can stay there for all I care, but I was able to get it off but I wanted to make sure that this was pushed together because we have to keep tension on this. So that should hold the ball in there a lot better. The idea is to keep tension on that ball. The ball's snug up against it. You can barely see it move, which is kind of, I think, what you want. And just turn it both ways and make sure that it You see the wheel going back and forth there, right there? That's nice. Down. And this one back and forth here. And the wheel is not all wiggly woggly in there. I was just putting a little actuator lever back in. Just then. Yeah, I don't think that epoxy's coming off of there. Epoxy's really good to use when practical. I mean, if your tolerances are, you basically have no room for it. But we have all this extra space here on the outside of this that doesn't come in contact with anything. Okay, so let's plug us back in. Oh, look at this. It's a beautiful thing. Reach the button now. I should probably put a little bit of contact cleaner in there, just for the heck of it. See what I can do about cleaning this up a little bit. The Manhattan label literally has some scratches in it, so there's not much you can do about it. The only thing I would consider is maybe just removing the Manhattan logo off of it. It's messed up anyway, and it kind of doesn't fit with the... It's mine. I get to do with it what I want. I'd rather have it say nothing than have something that's not Amiga. What do you think? Yeah, I mean, the Manhattan logo is messed up. I can make this mouse look really clean if I get rid of that logo. That's what I'm going to do. All right, the reason why I had the idea, actually, I wasn't really thinking about whether I would get rid of the logo, but with a magic eraser, that should probably come off of there. So I was going to use a magic eraser anyway to clean the scuffs off of it. That was my girlfriend getting home. She brought home blueberry pie. See that? It's coming right off. By the time I get this back, so yeah, it's interesting. That one corner that was broken is compromised by the fact that it has a hole, and the hole's very close to the edge of the PCB. So that's one thing that you think about when you design a PCB. You know, how close are your holes to the edge of the board, and is there going to be any strain put on them? I mean, if there's no strain put on them, then, you know, it's a very static thing. But mice are mice are like the #1 human interface. I think even by the time this one was made and designed, they knew. I need ending shot because we're done now. And we've replaced the cord with a very nice serial cable that has actual screw terminals on it, so you can screw it into the back of your Amiga, because as everybody knows, Amigas have screw terminal, not really screw terminal, just a screw mount, the standoffs that are next to the DB9. You know, keep that mouse located in there. And yeah, so another one fixed. The click tells you that it works. I guess we could plug it in one more time on camera. It's actually a pretty nice mouse. I'm running it on this wooden table. It's not the best. Here's a flatter surface. And that's it. We fixed it. Thanks for joining me, friends. We'll see you on the next one. Make sure to subscribe and don't give up on me. I'm just waiting for somebody else. Have a good one. Bye.